Yeah. Hello students, welcome to the session. Today we are going to discuss about trigonometric identities, and we'll solve a few problems on them. So to begin with, let us discuss about the types of angles, types of measures of angles like we come across in trigonometry. Basically, like you have sexagesimal, and you have this circular measure, and you have one more called as gradient measure, but we don't use that anymore. So let us talk about these two. The sexagesimal measure is also known as a degree measure, and you all might be knowing like 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds, right? So when you come across like angles in decimals, you have to take them into minutes and seconds, and then you do the calculations accordingly. And the circular measure is nothing but you convert it into, like we talk about a circle, right? Like what is the angle at the center of the circle? This is 360 degrees. Right, so 360 degrees correspond to the length of the arc is 2 pi r, and if I take the radius as equal to 1 unit circle, if you say, then 360 degrees is equal to 2 pi radians. We call in circle we call the angles in radians. Here we call it as in degrees, right? We read it as radians. So the standard form is like pi radians is equal to 180 degrees. This is how we convert like the degree measure into radians and radian measures into degrees. So this we all know, right? Now let us get into the trigonometric identities now, like trigonometric ratios. What are the trigonometric ratios we know? We know sine theta, we know cos theta, we know tan theta, we know cot theta, we know sec theta and cosec theta, right? And we talk about these ratios in terms of right angle to triangle, where you have an angle theta, and say this is the opposite side and this is the adjacent side and this is the hypotenuse. So we always you might be knowing about SOHCAHTOA, which we used to remember, right? Like what are the ratios of sine, cos, tan in right angle triangle. So I'm not going to tell you that, don't worry. You all know that, right? So what is sine theta here is opposite by hypotenuse, and cos theta is also adjacent by hypotenuse. I'll tell you why I'm talking about these two. And at the same time, tan theta is opposite by adjacent, right? So if you look at these two, opposite by hypotenuse, and in a right angle triangle, we know that the hypotenuse is always greater than the opposite, the remaining two sides, like either opposite side or adjacent side, whatever it is. So this hypotenuse is always the longest, right? So when you have the longest side in the denominator, the longest, the biggest value in the denominator of a fraction, the value is never going to cross 1. Right, like unless, see, it will be equal to 1 only when the O and H are equal. So these values are always less than 1. That's why sine and cos are called as bounded functions, because they cannot go beyond the values of 1 and minus 1. We have 1 and minus 1, which these trigonometric ratios lie in between. Like only cos theta is also between these two, right? But when you talk about tan theta, we are never sure like whether opposite side will be longer, means whatever side like you're talking about. If you see, if you say here that the adjacent side is longer than the opposite side, then I consider an angle theta here, then my tan theta, say theta 1, tan theta 1 will be again bigger than 1. So these values have no boundaries. So tan, cot, sec and cosec, these have no boundaries, right? They are not bounded actually, like they have infinite values, like negative infinity to positive infinity, you keep going. So only the bounded values here are sine and cos in trigonometry. And you might be well knowing that sine and cos, when you compare these two, cos is an even function and sine is an odd function, right? Now what can we do with these ratios? Like what are the relation, like you can find out the relation between these two ratios, like picking two at a time. Say if I take sine theta and cos theta, the value of sine square theta plus cos square theta is equal to 1. You can check this by using your values, or else maybe you take the triangle and use Pythagoras theorem. You get opposite square plus adjacent square by hypotenuse square when you compare these two, which is equal to 1, because this value is equal to the hypotenuse square, right, by Pythagoras theorem. So this is one identity which we are going to use today for finding different values of ratios of trigonometry which we are asked to find. And then you have one more rule, like secant square theta minus tan square theta is equal to 1, and cosecant square theta minus cot square theta is also equal to 1. So these are the three basic identities which we use in solving most of the trigonometric questions. And these also follow from the same thing. You can use this, or you can use this one, the identity 1, to figure out these two identities, like secant square minus tan square is 1, or cosecant square minus cot square is 1. Right, now there are I want to talk about the double angles and compound angles of trigonometric ratios also. Suppose I have two angles, say A and B, and I want to know what will be sine A plus B, right? Then this is given by sine A cos B plus cos A sin B. And similarly, okay, if you use plus or minus, so this will be plus or minus. You know this, right? Like then cos A plus or minus B will be equal to cos A cos B minus or plus sin A sin B. This is one more identity which we use, and there is a formula for tan as well, but I don't think we are going to use it today. But let us have a quick this one, like tan A plus or minus tan B by 1 minus plus tan A tan B. This is one more identity which we are going to use. Right, now I have sine A plus B is equal to sine A cos B plus cos A sin B, right? And I have sine A minus B is equal to sine A cos B minus cos A sin B. If I add these two, what am I going to get? So I have sine A plus B plus sine A minus B would be equal to 2 sine A cos B. So whenever I come across something like sine A cos B, I can write it as sine A plus B by 2 plus sine A minus B by 2. So this is a formula which we are going to use. At the same time, you can also do, like if you have cos A plus B and cos A minus B, if you use these two also, like if you subtract, say if I want to add these two, say cos A cos B plus, so this is minus sine A sin B, and this will be cos A cos B plus sine A sin B. And when I add this, cos A plus B plus cos A minus B is 2 cos A cos B. So simply you can say 2 cos A cos B is equal to cos A plus B by 2 plus cos A minus B by 2. Right? And similarly, if you subtract, what are you going to get? Like if I subtract, say let us say we subtract this from this, then what will I get? Like I get if I write it here, cos A plus B is cos A cos B minus sin A sin B, and cos A minus B is cos A cos B plus sin A sin B. Now I'm subtracting, say okay, I would have written this one on the top, so this is equation 1 and this is equation 2, so I'm doing 1 minus 2 so that I don't get any negative values. So what will I get? Basically cos A minus B minus cos A plus B. Why I am doing this, like why I am subtracting second one from the first is, like when you subtract, these two get cancelled and these two will become positive. If I subtract this way, these two will be negative for me, and again I need to take minus common and do that stuff. So I'm doing the other way around, right? So you get 2 sine A sine B. So simply if I want sine A sine B, I can have cos A minus B by 2 minus cos A plus B by 2. Right? This is a compound angle rule which we are going to use in deriving some questions, right? Now let us talk about one rule, which is the componendo and it is also called as componendo and dividendo rule, like which we can apply in trigonometry also. Maybe you all might be knowing, if you have P by Q is equal to say A by B, then what can you say is P minus Q by P plus Q is also equal to A minus P by A plus B. This is called as the componendo dividendo rule. So what I did is I found the difference of the numerator and denominator. Here also the same, and then added both of them, then still the ratio holds good. This is called as the componendo dividendo rule, right? This is also we are going to use in some cases when we come across, but I don't think we're going to use this today, but keep this in mind, like when we do it in further sessions we might be using this, right? Now we have seen the compound angles. Now what if I want to find, this is called as a double angle rule also. Suppose I want sine 2 theta, like 2 times the angle I want to find. So how can I do this is like sine of theta plus theta, right? So this is nothing but, like if you remember the previous formula, like sine A cos B plus cos A sine B, you can use sine theta cos theta plus cos theta sine, because the value, the angle in both the cases here is theta, so there is no difference. So you can simply write it as 2 sine theta cos theta. This is how you get sine 2 theta is 2 sine theta cos theta. And if you are doing cos 2 theta, same rule if you apply, cos theta plus theta, which is cos A cos B minus sine A sine B, which is cos square theta minus sine square theta, right? This can also be written as, since we already know, right, like what do we know? Sine square theta plus cos square theta is equal to 1. From that I can write this as 1 minus sine square theta minus sine square theta, which is 1 minus 2 sine square theta. Or this can also be written as, if I don't change this to sine and I just change this to cos, I get 2 cos square theta minus 1, right? This is one more value. Now see, what if someone asks you to represent all the trigonometric ratios, say in terms of tan. So I want sine theta, I want cos theta, I want sec theta, I want cot theta, I want cosec theta in terms of tan. Say I want everything of this in terms of tan. So what can we do? How can we represent, right? So these two are straightforward. Maybe cot theta can be simply written as 1 by tan theta, since you all know cot is the reciprocal of tan. Also we have secant square theta is equal to 1 plus tan square theta, or since secant square minus tan square theta is equal to 1, secant square theta is equal to 1 plus tan square theta, right? So I want secant theta, which will be equal to root of 1 plus tan square theta, right? This is sec theta's value. Now if I want to find cos theta, this is 1 by sec theta. See, I'm going in a way that I connect everything which I get in order, right? So cos theta is 1 by root of 1 plus tan square. So I'm expressing each and every angle, every ratio in terms of tan. Next, what else we are missing on? Like, okay, this cos is also done. Now cosec and sine. So sine theta, if I want to find sine theta, because we can reciprocate to get this cosecant theta, we'll find the sine. What is sine? Root of 1 minus cos square theta, as sine square plus cos square is 1. So sine theta can be written as root of 1 minus 1 by 1 plus tan square theta, right? Because cos theta is 1 by root of 1 plus tan square theta. So that's what I'm writing here. So what will be sine theta? Root of 1 plus tan square theta minus 1 by 1 plus tan square theta. So which is tan theta, because 1 and 1 gets cancelled. So root of tan square is tan simply. So it will be tan by root of 1 plus tan square theta. And then we have the cosec theta value, which is nothing but root of 1 plus tan square theta by tan theta. So this is how you can change any angle to anyone. Like, see, suppose here we change everything into tan. Say sometimes they might ask you to change it into cot, like they want every trigonometric ratio in terms of cot, or every trigonometric ratio in terms of cosec or secant, whatever it is they ask. Use these 3 rules and you can find out all of them in all other 5 trigonometric ratios into the 6th, whatever they are asking for, right? So we have seen what is sine 2 theta, right? So this is what is a mathematician always like. When he finds something, a mathematician is never satisfied. Like, he always wants to do more and more in math. So when he got this, he wanted to know what will be sine 3 theta and what will be sine 4 theta and cos 3 theta and so on. So let us discuss on first what is sine 3 theta. So this can again be written as sine theta plus 2 theta, and you can use the same old this one to find out what is sine 3 theta. It is nothing but 3 sine theta minus 4 sine cube theta. If you use the compound angle formula here and try, you will definitely come to this one. You can easily derive this one, right? And similarly, cos 3 theta will be 4 cos cube theta minus 3 cos theta. So these are also the formulas. These are compound angles, like where you have 3 theta. This also can be used in solving some problems. Okay. Now let us solve some questions basing on these identities we learned so far. The first one is to find the value of 3 times sin x minus cos x to the power of 4 plus 6 times sin x plus cos x whole square plus 4 times sin power 6x plus cos power 6x. Here we use some algebraic identities also, which I don't think need to be explained to you. You know, right? Like a plus b whole square and a cube plus b cube and these type of formulas you know anyways. So the first what we will do is we will simplify every part of this into squares, because we know the relation between the ratios when they are squared, right? So we will do this as 3 sin x minus cos x to the power of 2 and whole square, plus this can be simply written as sin square x plus cos square x plus 2 sin x cos x, right? Plus this can be written as 4 times sin square x whole cube plus cos square x whole cube. Now I'm getting this into the form of a cube plus b cube, right? Now if I expand this, this will be sin square plus cos square and minus 2 sin x cos x whole square is there on the top, plus 6 into this value is equal to 1 plus 2 sin x cos x. You can write this as sin 2x also, but let us see, if needed we'll write plus 4 times a cube plus b cube. What is the formula of a cube plus b cube? A cube plus b cube can be written as a plus b times a square minus ab plus b square. So let me write that a plus b. Here a is sine square x plus b is cos square x times a square is sine square x whole square minus sine square x cos square x plus cos square x whole square. Right? Now this can be written as 3 times this is equal to 1 minus 2 sine x cos x plus 6 times 1 minus 1 plus 2 sine x cos x plus 4 times. Now this value is also equal to 1 into this one is sine power 4x minus sine square x cos square x plus cos power 4x. Right? And this is whole square again. Now when we expand this is 3 times 1 plus 4 sine square x cos square x minus 2ab is 4 sine x cos x, right? Plus 6 plus 12 sine x cos x plus 4 times. So this can be written as I'll write it as sine square x minus cos square x four times sine a plus b times a square minus ab plus b square I write this as sine square x minus cos square x whole square. Then this is only one time, so I have to subtract one time, minus 2 sine square x cos square x, which you multiply with 4, it will become 8. 8 sine square x cos square x, right? So let me write this into this. So let us write the expression here again. I'll write it down. 3 times 1 plus 4 sine square x cos square x minus 4 sine x cos x plus 6 plus 12 sine x cos x plus 4 times sine square x minus cos square x, let us plus cos square x whole square. So I have added 2 of them, so I need to subtract 2 of them, so plus so minus 4 into 3 sine square x cos square x, right? Now if I simplify this, 3 times 1 is 3 plus 12 sine square x cos square x and minus 12 sine x cos x plus 6 plus 12 sine x cos x plus this is 1 into 4 is 4, and then this is minus 4 3s are 12 sine square x and cos square x. I think you understood, right? Like here this sine power 4 minus sine square x cos square x plus cos power 4x, this one we are writing in the form of a square plus a plus b whole square. So I want it to in the form of a plus b whole square because I know that it is equal to 1. Sine square x plus cos square equals to 1. So I'm adding these two. So to make it whole square plus whole square, I need plus 2ab term here, but I just have ab. So what I have done is I added plus 2ab and then I subtracted 3 times that ab, because I added 3 times there, right? But why is this 4 coming? Because the 4 is multiplying with the entire expression. So I multiplied this 4 here, right? So when we look at these terms, like this minus 12 sine 2x and this one and this one and this one gets cancelled, so you get the value as 13. So the value of this entire expression, the bigger expression here, became simply 13. This is the value of this entire simplification, right? So here the formulas we used are the one thing we used is sine square x plus cos square x is equal to 1. This is fine. And then the formula we used is a cube minus b cube, or a cube plus b cube. Yeah, a cube plus b cube we used, which is a plus b times a square minus ab plus b square. These are the formulas which you need to remember a lot. Okay, and then we used one more formula to write, like a plus b whole square is nothing but a square plus 2ab plus b square. When you don't have this 2ab, I just have, see, suppose I have a square minus ab plus b square is there, and I want to change this into this form. So what can I do? I can simply add 3ab and subtract 3ab. So I can write this as a plus b whole square, because this entire thing will become a plus b whole square, because these two will give us a 2ab plus 2ab, because 3ab is positive. So a plus b whole square minus 3ab, that is what we wrote it here, right? And the next question we want to see here is find the boundaries of a, the value of a, like where it lies, like whether it lie between 0 and 1 or 1 and 0 or 3 by 4, 5 by 4, 6 by 4, 7 by 4. Where is it lying? Like, is it between always greater than 0 or less than 0? How will be the values, right? You have to specify whether a is falling in between a particular interval or not, right? So let us try. So here a is equal to sine square theta plus cos power 4 theta is given. Let us write as cos square theta into cos square theta, right? Sine square theta plus cos square theta into cos square theta. Now what can be the value of cos square theta? Tell me. Cos square theta can be always less than or equal to 1. And actually I can also say it is lying between 0 and 1, because cos square theta is a positive value always, right? So this value will be less than 1. And now if you look at this is always equal to 1 actually, and you are multiplying something to this, right? So that means what? The value of a is always less than or equal to 1. So this can be simply written as less than or equal to 1. So a is less than or equal to 1. So one boundary we found, like the upper limit or whatever you can say, a is falling less than, a is below 1 always, right? This value will be always below 1 or equal to 1, right? It can be equal to 1 or below 1. Now let us try and see if there is any upper bound possible for this, right? I mean, sorry, the lower bound. Now a can be written as sine square theta plus cos power 4 theta, right? So we'll write this into cos square theta. So it can be written as 1 minus cos square theta plus cos power 4 theta, right? So we can write it this way. Then what we can do is 1 plus cos power 4 theta minus cos square theta we'll write. Now I would see, generally whenever an expression comes, any expression is there and you want to find the maximum value or minimum value, the thing you need to do is make it into a complete square. When you make it into a complete square, you will always be in control of the expression, because you will definitely know that it is positive or negative. For example, if I say here cos power 4 is there and cos square is there, and I am never in control with the values unless it is a whole square. Right? If it is in a whole square form, I'll be in control, like say this is bigger or this is bigger is what I can say. Right? We never know like which one is bigger here. But actually when you look at this, both of them are even functions and you can say this is bigger than this. That conclusion you can make, cos square is bigger than cos power 4, because a fraction raised to the highest power will always be smaller value, right? Like a fraction which is less than 1. So I am trying to make this into a complete square. Let us see how we can make this. I can write as cos square theta whole square, and you see this is a square. So if I want 2ab term minus 2 times a is cos square theta, and b I don't have any value, so I will take it as 1 by 2, because see when I simplify these two I get cos square back, right? So this term I'm writing it as 2 times cos square theta times 1 by 2. And so see now a square is there, 2ab is there, I want b square. What is b for us here? 1 by 2. So I add 1 by 4 to it. So if I add 1 by 4, I cannot simply do that because it will change my value. I have to subtract it at the same time, right? So now let us use these two numbers and simplify. 1 minus 1 by 4 will be equal to 3 by 4, right? Then this entire thing can be written as plus it is cos square theta minus 1 by 2 whole square, because this can be written as 1 by 2 whole square. Now a square minus 2ab plus b square, so I can write it this way, right? Now what can be the maximum value of cos here possible? What is the value possible? This is always positive value, and which is definitely less than or equal to 1. It is not going to bigger value, right? So what will happen? So this entire value, if I talk about this entire value, this is a positive number I have, and I am adding it to 3 by 4, then I can say this value is definitely greater than or equal to 3 by 4. It will be 3 by 4 when this entire value will become 0, right? That is cos square theta is equal to 1 by 2. That means I think theta is 45. Theta is 45. It will be equal to 3 by 4, right? So this value is bigger than 3 by 4. That means our a is bigger than 3 by 4 and smaller than 1. So this is how you find the boundaries, right? So the given expression's value is always between 1 and 3 by 4. And the next one is to find if f of theta is always greater than or equal to 0 or less than or equal to 0. If f theta is given as sine theta into sine theta plus sine 3 theta. We have to figure out if this is positive or negative. That is the meaning of this question. So if I consider this sine theta times sine theta plus sine 3 theta, I can write it as sine square theta plus sine theta into sine 3 theta, right? Now we know that cos 2 theta is equal to 1 minus 2 sine square theta, right? So 2 sine square theta is equal to 1 minus cos 2 theta, which will give us sine square theta is equal to 1 minus cos 2 theta by 2. So I will write this as 1 minus cos 2 theta by 2 plus. Now see, earlier we discussed, what did we discuss? Like sine A, sine B. If I want sine A, sine B, what is it? It is cos A minus B minus cos A plus B, right? Did we discuss this? Sine A sine B is cos A minus B minus cos A plus B. So instead of this sine theta 3 theta, so here I am considering this as A and this as B. My theta here is 3 theta is equal to A and theta is equal to B is what I am considering. So I can write this in the form of cos A minus B. So cos A is 3 theta minus theta minus cos A plus B. So cos 3 theta plus theta, right? Can we do that? And by 2. Correct? Now what can we do is we can take this half completely out. This becomes 1 minus cos 2 theta plus this will be cos 2 theta. 3 theta minus theta is 2 theta and minus cos 4 theta, right? Right. Now what this cos 2 theta and cos 2 theta gets cancelled, and you get 1 by 2 times 1 minus cos 4 theta. Now 1 minus cos 4 theta, what can we write this 1 minus cos 4 theta as? See, we already know 1 minus cos 2 theta is 2 sine square theta. So here I have 4 theta. 4 means I'm taking the value of theta as 2 theta. So I can write this simply as 2 sine square 2 theta. 2 sine square 2 theta, which will give me sine square 2 theta. And it is evident from this, like say sine square is nothing but sine 2 theta whole square, which will be always greater than or equal to 0. It will be greater than 0 for all the values when sine theta is not equal to 0. It may be negative, positive, but when you square it, you are going to get positive. So this is the solution for this, like f of theta is always positive, like greater than or equal to 0. And then the maximum value of cos alpha 1 into cos alpha 2 into cos alpha 3 so on cos alpha n is how much? What will be the maximum value of this, given that the values of these angles like alpha 1, alpha 2 and so on alpha n are taken between 0 and pi by 2. We are not considering values above 0 and pi by 2. But he also gave a condition that cot alpha 1, cot alpha 2 into so on cot alpha n is equal to 1, right? Let us try to solve this. So this one, if you consider, it is nothing but the product. If I say I runs from 1 to n cot alpha I, this value is given as equal to 1, right? Now if we use these trigonometric ratios, I can write this as cos alpha I by sine alpha I, which is equal to 1, and this product can be applied to both of them separately, like pi I is equal to 1 to n cos alpha I by pi I is equal to 1 to n sine alpha I is still equal to 1. So if I take this now, if I cross multiply, what will I get? Like pi product of these cos angles will be equal to product of these sine angles, right? And what if I multiply with cos alpha I on both sides? Like I'm just, you can multiply it, the product still remains the same. So pi I runs from 1 to n, I multiply with cos, then it becomes cos square alpha I is still equal to pi I runs from 1 to n sine alpha I and cos alpha I. Then this can be written as pi I runs from 1 to n sine 2 alpha I by 2, because there is no 2, right? So this 1 by 2 I can bring out of the product, which is nothing but 1 by 2 whole power n, because 1 by 2 times 1 by 2 times 1 by 2, which is multiplied n number of times, so it will be 1 by 2 n. Product of I is equal to 1 to n, simply sine 2 alpha. So the entire product, like the cos alpha 1, alpha 2, alpha 3, or else whatever it is, this equal to is equal to sine 2 alpha I from I running from 1 to n, right? So the product pi I is equal to 1 to n cos square alpha I is equal to 1 by 2 power n into. Now if you look at this sine 2 alpha I, what we are looking for a maximum value, right? Like what can be the maximum value of sine? See, the maximum value of sine function can always be equal to 1, or less than 1 is the smaller values. Like what are all the possible values, and you will say it is less than or equal to 1, and the maximum value possible for this is 1. So I can simply consider this as 1, because I am looking for the maximum value but not for any other value, right? Now I want only the product of alpha n's but not square. So then what is it? Pi I runs from 1 to n, I have cos alpha I is nothing but 1 by root of this 2 power n, which is nothing but 1 by 2 power n by 2. This is the maximum value for this. So the maximum value for this is 1 by 2 power n by 2. That's the maximum value of this product, right? So I hope you understood the trigonometric identities and the respective formulas. Let me check if you have any questions. We'll quickly solve them. So I don't think you have any questions, so I didn't get any of them. Keep watching Toppr live, and if you have any questions, keep us posted, so we'll solve them and get back to you. Till then, Satish from Toppr signing off. Thank you.